So hello all, welcome back to Android. So today we have a very exciting session. We'll learn about how to create dynamic histograms and box plot, and we can analyze output using GPT. So hope you know about histograms. So a little bit of histogram and the box plot. So histograms are basically charts like this, so which actually helps to analyze data, any kind of continuous data, into understanding what is the variance and the distribution of the data. So that helps any person who just looks into data or the analyst to understand more about the data set in terms of how much it's your skewness it is, how much it is having a kurtosis, what is their mean, what is their average, what is their distribution, how is the variance of the total data looking like. And it's basically looking upon continuous numerical data. So this particular sheet will give the analyst a total understanding about how this particular data on the sample data distribution will look like. Okay, so we are hearing about normal distribution, so we will see how much it actually tracks a normal distribution or not. And we will also see a box plot here. Box plot is nothing but we actually, or the candlestick plot is nothing but we actually find the variance of the data in terms of what is the lowest, the highest value of the data, and also we will see what is in between various quartiles. So we got 4 quartiles like Q1, Q2, Q3, Q4, and what is the outliers. So that means that 25% of the data on either side of the data set will be outliers. So 50% will be data that will be coming in between the box. So we'll see more into that. We talk about how the variance of the data is all about in histograms, using histograms and box plots. We'll also see the outliers as mentioned, what is the number of count of the outliers in the whole data set on a dynamic data set, and also the sum of the outliers, so we can see that how the skewness has happened, whether it's a negative skewed or a positive skewed, and aspects like that. And also we'll sign the IQR, that is basically the interquartile range, that is the 50% of the data that is removing the positive and the negative outliers. We'll also see how the particular descriptive statistics can be analyzed by GPT. So these are all the descriptive statistics that comes out from the data of the chart. So we'll understand what is all about the minimum, the first quartile, third quartile, what the maximum, the value of the particular data set, and we will see the mean, median, mode, the skewness, kurtosis, the standard deviation, variance and covariance, and many aspects like that. So this will be very helpful for a statistician, so he will actually understand the analysis of a particular data in a very comprehensive mode, and that particular reply or output is given by GPT. So we'll come back to sheet now, so just don't need this here right now. So yeah, so I'll just remove all the backgrounds. So just the data set first. So if you can see, this is the data set. So this is the data set that contains almost like a total of 1000 line items, so including the heading, that is 100,001. So this is basically about opportunities that has been created in Salesforce, or a particular tool for that matter, a CRM tool or whatever that you can say. So we have seen the data has been mentioned in various opportunities. There are 1000 opportunities here. So just click SL and control down, so you can just see 1000 opportunities are there. So the opportunities or line items are either lost or won, and the sales outcome, if it's lost, is 0, and if it's won, it's 1. So this is what this particular data should read like. And we can see that we have mentioned the data in terms of the product, the industry, categorized in terms of product, industry, region, and these are the input fields to explain you more on this. So we have the opportunities listed in terms of its reporting status, its sales outcome, product wise, industry wise, and region wise. Okay, so that is the significance of this particular input data. And apart from that, there are certain other parameters also mentioned. So what is the relative strength of the segment? Relative strength of the product in the market as per third party ranking, higher the value indicates better strength. So how is this particular deal or this particular valuation actually helping the trade off in terms of its relative strength? Okay, so that is what it's like 1 to 100. So this is 45. And what is how much is this particular deal affecting as a profit to the customer? So a person who is buying this product, how much with this deal will help as a profit. So here it's mentioned as 2.11 for this particular deal. But if you can see also, this is a lost deal because this was an opportunity that is lost. So this particular value or profit is just notional, it's not really affected the organization. And the name of the organization for that matter is WSCS. So I don't need to elaborate more on what this organization is, it's just a fictitious character. And this is the profit for the company. So this is the profit for the customer, and this is the profit for the company. So if the deal happens, so this particular deal would have happened, it should have been given 29% of the total profit. I mean, it's like 29% of 10.29 million. So that will be the profit of the company. And in this particular case, in this column, WSCS proportion the joint bid. This particular deal, whatever the deal or the line item that we mentioned here, if it's closed, the thing is that the share of this particular deal is not confined only to the organization. It is actually shared between 3 people. So it happens in organization when it's a deal is being cracked by 3 different stakeholders. So there is a proportion of bid, and that bid or that particular share of the percentage will definitely depend upon various attributes like maybe region, maybe product, maybe industry, whatever it is. So it is all, I mean, it's all basic things that companies do. So this particular bid, it has got a 66% proportion in the joint bid, and that is contributing more to the company, that is WSCS. If you can see, this is only 48%. So this product is fences and it's like consumer goods, so that the bid is lower. So that is what this mentioned. And the lead conversion class, it's connected with the exhibit here. It's basically classification of leads by the sales team is then what is the effectiveness of the lead. That is mean it's like an excellent, very good, fair, low chance. So you can see that this is a fair chance. This is a fair chance because it's F, and this is an E, and that is where it got closed, and that is excellent. So it's basically categorization based upon how the classification of leads is done by I mean opinion from the sales team. And this is basically revenue or sales value in million, and that is basically the range only that comes from this I2, because here it's a decimal, so it's just got truncated to only, sorry, no decimals at all. So that's basically, you use a formula called truncate, and you mention the value and you mention the places. The here number of places are 0, that's why it is. So just drag it here and you can just commit it. So this is the data. So this data has got almost like 1001 data points, and if you just see, every count is 1001. So you can ensure that there are no gaps in between, there are no missing values in between, because everything is showing 1000 only. So you can also do this, like, I mean, you do this activity, or rather you go here and filter, and if you see a blank somewhere, if you see a blank somewhere, then there are some missing values. So you can see that here there are no blanks here. That's how you understand missing values. If missing values are there, we have to just I mean replace it with some value, because if it's numeric data, discrete data, then actually you will have to, or a continuous data, then we will have to use some kind of 0 or something. So it's a must ensure that whatever analytical data that you are using for the source has to be as clean as possible, and all these missing values has to be removed at any cost. So here also you can see that there are no missing values, or you can here see no missing values, or there is no blank here. So if, say for example, I just delete this, so here again it will show some blanks, right? That is what the point I'm saying. So there should be no blanks. So you can just see here also there are no blanks because it's basically the product details that you mentioned like that. So this data set is ready for analysis, so it's clean. Okay, so now we'll come to the sheet. Okay, so what we are trying to do, just give you an understanding. What you're trying to do is that for the analyst to understand this particular data set, he should actually look on all these parameters. So these are all filter parameters because there can be a permutation that this particular deal or any particular deal for that matter can be varied in terms of bond loss, or it can be like varied between products, it can be varied between industries, and it can be varied between regions. So to get the status, so he can actually filter this particular data. So if I want to learn as an analyst, I want to learn the particular outcome of this total set of data that is having an attribute that is connected with one, and I want to check how this particular deals are happening from the entire data set against the attribute called product and industry called banks and a particular region called UK. So from this data I should get the filtered data based on all the filters that I give, right? So I will do that. So that I'll show you how to do that, and against that particular combination, what is the relative strength, what is the profit of the customer, all these things should come. Okay, so the entire list of filter data should come, and that should actually give in the track of what is the relative strength, what is the profit of the customer, sales value of the customer, and the profit percentage, WCS proportion, and sales in millions for that matter. Okay, so right now we just not take that because this is not a not a numeric variable, this is a categoric variable, so we just remove that. And I don't think that we should take the sales value in million that is truncated with no decimal, so I'll just use this. So I just don't use these two data as of now, I just use these till k. A to k is the data that I am going to use. So let's go ahead and do this. So if I want to filter this particular data based on certain parameters that I give here, so then I will have to use something called query. The query is a very beautiful formula, a very effective formula that we use for database search and wherever that we use to filter data. A lot of things can be done on query. We will look on to that. So before that we will have to create the filter parameters. So here what I given is that what is the reporting status. So nothing very much complicated on this, just go to data and just the data validation. So here the value of A2 comes from the drop-down range, and that is coming from this data. Okay, so I have just selected B is to B13, so B is to B13, so I don't need the entire B2 is to B13 also, I just need the first two columns, so that will give me first two rows, so that will be lost. Okay, so that is one, and I'm just clicking on the source file, so that is also data. So A2 is basically coming from the range that connects to the warrant status. So and again B2 is also there, so B2 connects to the data that is there on the D column, so that is basically D column here. Okay, so like that. So what I've done is that I've done for 1 2 3 4 5, so that is industry also. You go to data validation, so industry also it's connected to the data that is there on the sample, and D2 is the region, and D4 I'll just little bit elaborate on that. So D4 comes from sample data that is from G to K, that is tracking from this. Okay, just see this, it is from G1 to K1, so G1 to K1. So what a filter that we are giving here, there is also an outcome, and that outcome is based upon the relative strength of the segment. Okay, the profit of the customer, sales value, and profit percentage, and also WCS proportion to the joint bid. So that is how the output will come. Okay, so all set. So we have actually created the filters here. So if I have to tell you what I am trying to find out here, so I am just finding out from the entire 1000 data sets if what are the one deals, and for the product GTM sys, and connected with the industry called banks, and region I am not mentioning as of now, and what is the sales value in millions. So I just need to see the trend. So there will be a lot of line items. So particularly the output should be the entire filtered data connecting to all these attributes, and I should value this particular graph in terms of sales value in millions. So I just need to understand from the histograms how the trend of the total filtered data is actually representing to me. Okay, for that what I will use that, so just close all this. So when I put all these filters, so there are multiple filters here, I should get the data. So here is the data. So here you can see that almost like 49 numbers, and 49 numbers excluding the headers, that means 48 is connecting to this particular multi attribute search that is connected with one GTM sys banks. Okay, so these three parameters are here. Okay, so what happens is that, so this is the data. So I use a beautiful formula called query. So this is the query formula. So I'll just tell you what is this formula about. So just breaking it simple. So query, what it does, that we just need to correct the data first. So data will be sample data on past sales leads. So that basically the tab that contains the data, and I have selected A2 is to M. So A2 is to M. So I have selected till there. Okay, from A2 this value to the last value that is coming from the M column. So what I've done is that, and then I have just being descriptive on the select parameter or the query here. So what I say and what I ask this particular sheet is that select star, that means select all the values where B contains A2. Okay, so B is basically the column number. So what I am telling is that select all the columns where B contains A2. So B is what? B is this column, right? And B contains A2 is nothing but B contains this one, this cell. So it will check for that particular sheet where it is only one. Okay, so that is what first it did. So we are not stopping here, we are just continuing with other attributes also. So this has to be filtered other or attributes also, and then now it says that, and so we have, there's a particular syntax here because we started with double quotes, a single quotes. We actually keep the value that is from where we need to filter it in this particular sheet. And so I mentioned A2 here. So we just start with a single quote, then we put a double quote, and we put ampersand sign each and A2. So if there is anything missing, this particular code will not work. Okay, this formula will never work. So that is what it's all about. And D, so I just mentioned and parameter here, so that is operator here, and D contains B2. So same thing here also. So what is D? D is nothing but product, and this product should actually be filtered by what is there on B2. So that is what it says. So D contains B2, and coming down it will show select star where B contains A2, D contains B2, and E contains C2. So what is C2? C2 is industry, and that connects to E column. All right. So yeah, so C2, and F contains D2. F contains D2, and what is F? F is nothing but the region, and that comes from D2. Okay, that is all this particular data does. Okay, so I will tell you how this attribute also works. So just you can see, so you can see till here. So I'll just zoom out a little bit so that you can see it much better. So just leave this. So we'll just see from columns. Okay, so this is the data. So this data will only contain the won deals. It will only track the product, filter the database against the product GTMCs and industries banks. Okay, if I am putting something like UK, just see how it is coming. It's coming like this. So it's only tracks UK. So you can use it or delete it, whatever required. So I'm just using it for now. So it's again works. Okay. So that is done. So we are just tracking the performance based upon filters that is mentioned here. Okay. Now what will happen is that we need to create another parameter, and that is for the creating the bin and the frequency. Okay. So how this particular chart will work? This particular chart will work. This particular chart, if I just double click, you can just see the setup is it just tracks x-axis, that is bin in millions, and frequency. Okay, and this is bin in millions and frequency. These are dynamic. Okay, based upon whatever is there on the filter, all these things should change. Okay, so before coming to this, so this is the bin and the frequency, because if you see a histogram, it should contains the values that it's track on, that is called the bin, and this is basically frequency. This particular frequency comes from this particular data set, because we are tracking the sales value in million. So here, if you want to filter it or any of these output parameters, we are filtering it here. We are getting these values as mentioned from data validation. So we just select any of these things. What happens is that this particular thing will function, or this particular value will function. This is the formula where it says that if u1 is equal to L1, okay, u1 is L1, then just put this, drag this L2 is to L here. So what it means is that if u1 is equal to L1, let's see, if this particular, you see this is L1, this is D4, right? So okay, so we mentioned we need to get the output from this particular sheet, this particular value. So we just select this. So we just mention this as here. Okay, so this is equal to D4. Then it says that if u1 is to L1 is equal, u1 is equal to L1, u1 is equal to u1 is equal to L1. Okay, okay, then pull this particular sheet. And if u1 is equal to m1, then pull this particular sheet. And if u1 is equal to n1, then pull this particular values. And this is equal to o1, then fill this particular values. That is what it does. So I can just show you for an example. So here, if I am just mentioning sales value per million, so I want the report in a different manner, like profit to the customer in million, then what happens is that this comes here. Okay, and here the formula says is that if u1 is equal to n, is u1 is equal to m1, so u1 is equal to m1, then this particular data will come. Okay, so that is how we create the formula here. So what simplicity in very simple terms that I am trying to understand, make you understand. So let me take you more about what is the bin and the frequency. So these are the two axes from which the graph is being created. So this particular graph, as I mentioned, that is created from these two particular axes. So bin will be the x-axis and frequency will be the y-axis. So what is the bin and frequency? So this is the data from which this particular bin and frequency is being calculated. So I'll just very comprehensively tell you how to calculate this bin and frequency. So for that, I'll just create a filter here. So you can see this is the data set. So this is the data set contains with profit of customer based on the filters that we mentioned on the left side, right? So this is the data set, that is the outcome. So we are tracking the profit to the customer alone. Okay, so you can see that what is the minimum value? Minimum value is minus 0.2, and what is the maximum value? And that is 1.47. So we are tracking this particular data set with the minimum value of minus and positive of 1.47. So that is why we track from minus 1 to 3. So this, since the minimum and the maximum value is something in between these particular minus 1 and 3, because there is no value beyond 1.47 for that matter, of beyond 2 also it is not there, and there is no value less than minus 0.2. so there is minus 1, so that is no value beyond minus 1. Okay, so that is what this particular bin is all about. Okay, so hope you get it's nothing but the step is also the same. So if you can see that it's minus 1 plus 1 is 0, 0 plus 1 is 1. So this has to be very much, the step has to be similar. It's something that we're tracking on the graph, and graph has got a very specific parameter, because the step or the gradation should be even. Okay, it can be 2, it can be 2, 3, 100,000, whatever, but that has to be even. So that is what the step is all about. So here you can see the step is exactly the same, is 1, and we are tracking the minimum value and the maximum value, so that the entire data set actually comes in between the graph. That is the only objective. Okay, so now we come to the frequency. So you can see that here minus 1 is 0. So whatever is value is beyond minus 1 is 0. That is what this means. So this data set doesn't contain any values beyond minus 1. But if you can see minus 1 to 0, there are two values. Minus 1 to 0, there are got two values that is mentioned here. If you can see the data set, there are two values, minus 2 and minus 5, right? That is below 0 but not below minus 1. So that is what minus 2 and minus 0.05. So you can see between 0 and 1 there is 38 values. Between 0 and 1 there are 38 values. So there are a lot of 0.4s, 0.5s, 0.61 points. So there are between 0 to 1 there are 38 values. Now we can see that between 1 to 2, so 1 to 2 you can see 1.01, 1.05, 1.15, and there are 9, and beyond that there is no, beyond 2 there is nothing. That is where 0 was mentioned. Okay, this is very much required if you are creating a histogram chart. So what it does is that whatever data is there, it's pulled up based upon the filter that you are giving here. So you have filtered it from the profit of the customer in million. So this particular profit to the customer will automatically come here, because a formula I given is D4. D4 is nothing but profit to the customer, and here I given a formula like, if say for example, if U1 is equal to L1, if this particular value is equal to L1 relative strength, then this particular data will come, that is L2 is to L. So this particular data will come here. Okay, now if it is changing from U2 to M1, so if this particular value changes from U2 to profit to the customer, then this particular data set should come. From there we will calculate the frequency and the bin. Okay, and here if it's coming like U1 is equal to N1, that means that it's the sales value in million, then this particular N2 is to N should be the drop down. Okay, should be the data set that is being connecting here. So that is what. So we use the formula like if. So if U1 is, this is multiple or nested if for that matter. So we are just opening every single statement and then closing it all. Okay, so that we only get the data set that the particular drop down is being filtered to. We don't need all the reports at the same time. We need single report at the same time, and based upon all the parameters that is mentioned here. So here the formula is this, and automatically it will come here. And here, since it's asked for profit for the customer, so here is the profit for the customer, and this values is what is listed here. Nothing, no change on that. Okay, and as I mentioned, this is the bin and this is the frequency. So let me show you how to calculate bin. Okay, so bin is basically coming from A2 is to A. So A2 is to A is this, so this value. So I'll tell you how to calculate the bin. Bin basically changes with the data set here, because bin is basically calculating the higher value, the lower value, and we are actually gradating it even with a step. Okay, that is what the bin is all about, right? So since the data changes here dynamically here, this minimum value, maximum value can dynamically change. So as per this particular data, the bin should change. So that I have used a formula called sequence. Okay, and the syntax for sequence will be rows. That means that how many rows this particular bin should be there, or the sequence should be there, and this mentioned how many columns. So that is irrelevant here. You will keep one here because we need only one column of data here. Okay, we don't need multiple columns of data, so we need one column of data. And then we show the start, from where it should start, from which is the first point that we should start. Here it's mentioned bin is like -1. Okay, so that is where it starts, and then we'll keep the step. So here the gradation is 1 1 1 each, so you can keep 2 2 also. It's all depend upon the data that is required for you. So here it's a sad data set across. I have mentioned the gradation as 1, so the step is always 1. Okay, but you can see I just tweaked the formula a little bit. So here the number of rows, I have created a formula like AB minus A1. AB is nothing but the maximum value of this data set. So what it does is that, so this is the maximum value of data set, so it is max u2 is to u. So I just need to find the maximum value. So you just filter it here, you can see the maximum value here is 1.47, right? So that is what is mentioned here. Okay, and what is the minimum value? That will come from minimum u is to u, that is only tracking. What is the minimum value here? Just filter here, you can see the minimum is minus 0.2. Okay, so what it does is that sequence AB minus A1. Okay, so AB minus A1. So I am just calculating the row here because it has to be the row. So this is the row parameter here. Till here it is a row only. So we are creating a formula that this number of rows will directly connect with the highest value and the lowest value. So I am just reducing the highest value from the lowest value, and I am just adding 4 because I can add. I just not keep it abrupt, because the graph, if I mention here, so I'll just show you. So if I just remove this 4 here, what will happen? See, the bin changed to -1 and 0 1. So there are no equivalent values to actually track here, because beyond 0, okay, I need to have some gaps in between the graphs here, right? So if you get to see here, okay, this graph showing just 2 points here, so I just need to give some width for the graph. That is why I am mentioning something like, I'll just put this +4. okay, that depends upon the data that you have. And what I'm doing is that, okay, so now the changes and the graph also looks nice. Okay, because I just given some gaps here. Okay, so I'm just tracking the frequency based on that. Okay, so I have the minimum value, that is -0.2 and 1.47, and the bin is here. So dynamically I have selected bin here. So this is the row, and now we'll come to the column. Column is only one column, and start will be AA minus 1, AA1 minus 1. So what is AA? This is here, right? So again, to give some space, I am reducing that also. So just give a -1 so that it tracks much below -0.02. Okay, so it may be like -1.12 or something like that. Okay, so Z1 is nothing but the step is mentioned here. So this can also be dynamically changed. So if you want to step to 2, so here it will like 0 2 4 like that. Okay, here it's 1, so it is 0 1 2 4. Okay, so that is how I created the dynamic bin here, and that comes here because here I mentioned A2 is to A, so this is basically copying whatever is here. Okay, now for the frequency has got a formula. Frequency is nothing but in this particular parameter, or what is there below -1 from this data set. So what I do is that I just open the frequency and I select the data. So this is the data it is coming from, and the classes is coming from B2 is to, or you just select the data here, and that is W study. So here it is coming from this, right? So it is tracking against the X axis that is mentioned in the bin. Okay, so this is what, just drag it here and it will automatically come here. Okay, and from here I have created the chart. Okay, just if you can see here, I can just double click the chart and show you just setup, and here the X axis is bin in millions. Okay, and the series is the frequency. Series is basically the Y axis. So this is the Y axis, that is the frequency, and this is the X axis. Okay, and that is the bin. Okay, so just see the distribution. So we need to understand certain values from this, certain inferences from this particular distribution. So if we have filtered the one data only from the product GTM sys, from the industry banks, so the particular profit to the customer in millions. Okay, profit to million in millions. So just see there are a lot of opportunities here, and the opportunities, the highest will be like 38. 38 is coming between 1. Okay, that is $1 million. Okay, a majority of 38%, that is a standard distribution, almost a standard distribution. So some, you can just see some thin outliers, the thin tail, the tail is not exactly a normal distribution, but okay, fine, because majority of data is coming between the mean. Okay, so you can see the entire data, the frequency 38, the 1 is the total in millions, for it's coming 38 numbers. 38 numbers are coming for the value 1. Okay, here also you just can see that there are 13 outliers, which is totally amounting to 3.32, and there are positive outliers that is amounting to 29.74. Okay, we'll come to the inference later, but if you can see that there are 17.7 come from in the IQR range, and that is counting to 13. Okay, so since the total outliers of the negative and positive side are almost, the count is exactly the same, but you can see that it's skewed to the right because there are some positive deals that is happening more than the negative deals, or the lower deals, some higher deals are happening. That is why it is skewed towards, the distribution is skewed towards the right. Okay, so this has got a right skewed. Okay, this tail is much stronger because there are deals happening on the higher side. Okay, there are deals happening for 1 million, 2 million, 2 billion, and that is why it is coming like this. Okay, so now we'll come to the box plot. So to create the box plot, what we do is that we will come to certain data here. Okay, since I had to create two different charts, so I mentioned the same with this, basically the same. So we'll take this only. So this is basically U1. So U1 is nothing but the heading, that is the profit of the customer, that is coming from here. Okay, and this is, we are calculating various types of descriptive analytics or statistics, so that is called the minimum. So minimum is nothing but AA1. So AA1 is what we have calculated the formula here, and that is minimum, and AB is also there, which is called the maximum. So here from this data set we will come to the minimum. We will find the first quartile. Quartile is nothing but there is a formula called quartile is equal to quartile, and you just select the range that you want to find the quartile. Here it is this range, U2 is to U, and from there you are finding the first quartile. So we just see that that is the 25% of the initial values, so lower values, so that will be the first quartile. Then in between the first and third, that will be the IQR, so that is mentioned here. I'll come back to that, and this is the third quartile, and you just do that the same, and then you will find put 3 here, and you will find the quartile here. Okay, so that is 0.95. the maximum is basically the max function, okay, of the data. Median is nothing but what is the you just categorically, I mean, you just put the data in the increasing order, and what is in between that will be the median. So it actually calculates with the formula. Only thing is that it is connected to the data, that's it. And IQR is nothing but first quartile minus third quartile. So whatever is between the first and third quartile, and that will be 50% of the data of your data set, and that will coming to IQR. So we'll see how this particular values all makes an inference to. So mean is nothing but the average of the entire value. Just see that 0.68 is the average. So if you can see here, this particular value is almost tracks here because this is the mean. Okay, it's almost coming to 0.68. So that is how this has to be read as per the bin. A bin I have not mentioned decimal values, that is why it's showing like this. But for the purpose of understanding also, if I just mention bin in decimal values, then it will track exactly at 0. It will track the median, that is the average. So here I have mentioned you how to calculate the IQR. Sorry, I mentioned mean, right? So this is the mean. So it tracks the mean 0.684, and there is also an observation that the median is lesser than the mean, or the mean is greater than the median. So let's see how the inference all works in the due course of time. So in this video also we'll explain that also. So median, okay, just not repeat this here. Okay, just repetition of here. Okay, so let's leave as it like this. So we just understand the skewness. Skewness is nothing but whether it's positively skewed or negatively skewed. So we also understand how the outliers are actually putting their effect on the data so that it's getting skewed, or where the higher values, I mean apart from the median. So if it is the higher values will come on the right side, then it will be right skewed, and if the left side is left skewed. So we will understand the skewness. Skewness is having a negative parameter and a positive parameter. So if a data set is negative, there is an observation, and positive, there is an observation. We'll come back to that. Kurtosis is nothing but the how this particular graph is coming, like thick and thin tails. So there are graphs that has got higher wave, okay, and that we have got three types of Latikirkic, Kurtic, and Lipto and Kurto. So we have got certain three types of data sets on that particular kurtosis, that is negative, 0 and positive. So here you can see that the skewness, kurtosis is positive. We can see the standard deviation. Standard deviation is nothing but root of variance. So we have a specific formula here, connect to that, and we'll see the standard deviation here, and that is nothing but the root of variance. And variance, then again just connect the data set and understand variance. And covariance, how this particular, I just mentioned it just for the sake of understanding. So how this particular data set is connecting to what is the variance between these two types of data sets. So I just selected the bin and the x-axis and the y-axis basically, so it's showing a negative variance. Okay, let's come back to all these things. From this particular data I have created this particular box plot. So box plot which says that, so it is coming something where in between, right? So you can see that it is coming somewhere in between, so that it's a normal distribution almost like. So we can see that the lowest values are 0.2 and the highest values is 1.47. okay, that is the range of the data set. And what is coming between the IQR, that is between the first and third, is like 0.48. so we can see that it's 0.48, and 0.95, that is here, and -2 will be here, and your 1.47 will be here. So we on this particular box plot we can track all the highest and the lowest and what is becoming in the IQR. Okay, so we use that mainly in the stock chart where is the close, the maximum, and the median, all these things are mentioned. So that is what it is also relevant here. So this is the box plot. So after that we should understand what the outliers are. Outliers are basically the particular data that is beyond the left side 25% and the right side percentage of the distribution. So you can see that the count of the number of outliers are 13. So what we done is that we have created a formula called count, and if it says that count if u2 is to u2 where it is less than AE4. So it is basically taking the data set from here and AE4. So AE4 is nothing but first quartile. Okay, so wherever the first quartile is showing that it is stopping at 0.48, whatever is less than 0.48 it will take. Okay, in this data set, whereas less than 0.48 it will take. So somewhere from here 48, from here down all the data, the count it has taken. So that is coming to 13. Okay, and positive outlier is nothing but what is beyond the third quartile. So you can see that we have mentioned count if u2 is to u, but it is greater than AF2. Okay, so we'll come to AF2. So AF2 is nothing but the third quartile. Okay, so what is the count of values that is beyond 0.95? Come here and you will understand. So we'll take here. So 0.9, okay, somewhere else. So all these values beyond that will be the count. Okay, so you can see that is, and basically what is the number, the count, the total minus this, or what is in between, use the formula what is between the first and third quartile, that will use the count ifs formula itself. Here using the count formula because using only some one particular condition range. So you can see that this is the criterion, one single criteria range. So I use count is because I am using two different criteria. So one is that it is greater than the the first quartile, and one is that it is lesser than the third quartile. Okay, so I just take the sum but with the count, but I also require the sum because the distribution will work upon the total sum. So what I have done is that the same formula I use, that what is the sum of values that is less than the first quartile, and here what is the sum of values that is more than the first quartile, and what is the sum in between. Okay, then you can see that the outliers are lesser on the negative, so and the highest outliers are on the positive. That means that huge values here are pulling the graph towards the right side. So this is thick here, right? Okay, right. Okay, so from this particular data is mentioned here. I have pulled up or copied all the data from here, okay, towards here, so that we can see everything on this chart. And what happens is that I use the H lookup or the horizontal lookup formula. So it is basically when we use the vertical lookup formula, or we use a VLOOKUP formula when you have data in this form, right, where it's in column. So if you have to select a particular value from this particular cell and against the sales value, so that is what we mentioned. This particular will be the whatever lookup against, and this is what we get the value from. We put the index number as 1 2 3 4 5 based on the data that we select, but here we are using H lookup, the same formula that we use when you need it from a horizontal database. So here it's vertical that I showed earlier. Now we'll see how we can take it from a horizontal database. So how we'll do it is that we use the formula called H lookup. So what it will do, okay, H lookup will look at A65. So A65 is nothing but this, and it will return the range of the value from AD3 to ADQ. So we'll go here and we'll understand this is the data from where the range is being selected, and it will look for this value. So in this case it will look for the value called first quartile. So where is the first quartile here? The first quartile is here, okay, and that is the range, and index, what is the value that is here as a reference. So pull up this particular value, and that is 0.48, okay, and it's not sorted, so that is why we put solve and close it. Okay, and I have dragged this formula down because I need all the formulas down also, so that I will lock this formula with F4 and just dragged it and just dragged it, that's it. Okay, so wherever it pulls up the value what is there on the chart. So the minimum here I used a particular formula, just add this with a double colon so that it seems like a question. Okay, so all these things. So here I have come with the GPT formula. So what I used the GPT formula is that is equal to GPT. What does this mean and the value? So what does this mean and the value means what does this mean? IQR is 0.42. That is how GPT will read this. Okay, so this is the GPT output. So here just an understanding. So here the question is changed or altered a little bit. What I'm asking is what if is D70 and D71 for a data set mean? Okay, that is a question. So what is the question that GPT will read is that what if the IQR is sorry D17 and D71, right? So what is the mean is 0.7 D70. Okay, mean is 0.68 and median is 0.66. So that means that the mean is greater than the median. Okay, and the outcome is that if a data set is 0.68 and the median the mean of the data set is 0.68 and the median is 0.66, it's that the data is slightly positive skewed. It's positively skewed, that it is more on the positive side. That means that some higher values in the data set is pulling the mean slightly above the median. In general indicates that there are some outliers or extreme values on the higher end of the data set. These outliers are greater impact on the mean than the median, causing the mean to be higher. Okay, so that is not, without further information, this not to draw big conclusions. The only basically basic understanding that we can get from that is that the mean is greater than the median. That means that certain greater higher values towards the higher side, it is actually pulling the graph toward the right side. That is when the higher values are there, okay, than the lower values. The total of the higher values toward the right side of the graph is higher when compared to the lower. That is absolutely that we get from this data also. They can see that these are the high values and the positive outliers that is pulling into the right side, right? So that is the understanding from or output from GPT. Okay, here it's mentioning something on the kurtosis. The value 0.32 is the cursor calculated by the kurtosis software. Kurtosis is a statistical measure that describes the shape of the distribution. A positive kurtosis value indicates the distribution is heavier tail and a sharper peak compared to the normal distribution. With negative kurtosis value indicates as distribution with lighter tails and a flatter peak. So you can see it here. It has got a heavier tail and has got a sharper peak compared to a normal distribution. That is what kurtosis is. You can also see here it has got a heavier tail and it has got a sharper peak. Okay, you can see the median here is 0.7. That means that the mode is 0.7. That means that that is the value that is coming more frequently on the data set. That is basically the mode. Okay, this is skewness is minus 0.99. Okay, the skewness is the statistic measure of asymmetry of a probability distribution. Negative skewness indicates that the distribution is skewed to the left. That means that the tail of the distribution is longer on the left side. So you can see that the tail of the distribution is longer on the left side of the graph. Okay, that is the outcome from that. Okay. So these are all certain meaningful outcomes that is coming from the data. What you can see is okay. So this changes as per whenever you can just change the data input also enter. Okay. So I think this is a very lengthy session that we have taken. So I think from the data set you have some basic understanding on how to create query formula so that you create customized outputs using different attributes or varieties or attributes or different permutation combinations on attributes and get the output data as required. Okay, from there we understood how to create an histogram using a dynamic bin values and create the frequency, and then you plot the chart, and then you go to various descriptive statistics, and then you plot it as per the box plot or the whisker plot or the candlestick plot that people take in different ways. Basically, it's all seen, it's the same. And we see the outliers, the count of the outliers and the sum of the outliers and how it's affecting. And then we use an HLOOKUP format to actually pull up the values that is based and that is getting you data towards an horizontal data, and then we use GPT to get its interpretations on data. Okay, so hope you have a brief idea of or just rather a main understanding or just a basic understanding on how an histogram and how distribution works and how we can use a sheet to do that. This is just a basic. We'll go to more analysis and most complicated analysis in the days to come. So all the best. Thanks for the time spending here. Have a good day.